f of x is 3x plus 5, g of x is negative 2x plus 15. A, solve f of x equals 0. F of x is 3x plus 5. What it's telling me is that 3x plus 5 equals 0. So I replace f of x by 3x plus 5. This would say that 3x is negative 5, or x is negative 5/3. What is x when y is 0? That happens to be, if y is 0, that happens to be the x-intercept. They didn't ask me for the x-intercept, but that's what it happens to be. F of x is negative. Again, f of x is 3x plus 5, so I replace f of x by 3x plus 5. And now I just solve for x. This says that 3x is less than negative 5, x is less than negative 5/3. Where f of x equals g of x. Well, f of x is 3x plus 5. G of x is negative 2x plus 15. So that 5x plus 5 equals 15. 5x equals 10. X is 2. Now they didn't ask me for the coordinate point, they just said, where does f of x equal g of x? And then we're going to go to the graph and relate each one of those to the graph. Where f of x is greater than or equal to g of x. So where 3x plus 5 is greater than or equal to negative 2x plus 15. 5x plus 5 is greater than or equal to 15. 5x is greater than or equal to 10, or x is greater than or equal to 2. Those all have specific meanings. Now I drew the graph so that we can now talk about it. This says, where is f of x 0? For what x values? For what x values, y equals 0, x equals negative 5/3. So if I go to the graph, and here's the graph of those two functions. If x equals 0, on the function f of x, oops, looks like I have an error here. Cut and paste, cut and paste. This guy right here. This one's F. The other one's G. It says on this guy called f of x, which is this one right here, when y is 0, I'm on the x-axis. This coordinate point right here, where the graph crosses the x-axis, according to our calculations in part A, is negative 5/3, 0. Now I'm going to go to the equalities first, because then bring in the inequalities. It says f of x equals g of x. Where f of x equals g of x, this means this is the intersection of the two graphs. That's like solving a system of equations. Where do the two lines intersect? Where do they cross? And that's this position right here. And according to us, We don't know what the y value is, but we know that the x value is 2. But we know the y value is somewhere between 10 and the 11, something like that. So that's the intersection. Now, what does this have to do with the inequalities? This is the big gun. As I look at calculus in particular, and as I look for what we're going to be doing, especially in chapter 3, because all of this is beginning to set us up for probably one of the biggest chapters we do, which is the study of polynomials, which is and rational functions, which is chapter 3. It asked me a question. Where is 3x plus 5 less than 0? And what it's asking me, basically, I want to have y negative and not equal to 0. And for what x's? Why? Because it says y is less than or equal to 0. What's not given to me is an x value, so it's actually looking for the x values where that occurs. And I will be saying this over and over and over again because this is the key that unlocks a big door. It says when x is less than 5/3. Well, if you notice on the graph, 5/3 is where the graph crosses, negative 5/3 is where the graph crosses the x-axis. Now, if the graph crosses the x-axis, this means that below the x-axis, y is negative. Then it crosses the x-axis, y is positive. That's the visual. In order for y to go from negative to positive, it has to cross. Where the graph crosses is the x-intercepts. The graph crosses the axis at the x-intercepts. So any interaction that the graph has with the x-axis is going to have an impact on y. Whether y is positive, whether y is negative, and we're going to see y could actually stay the same. And then it says, and this is a hard one, by the way, because if you're interacting with two graphs, and we actually come at this from a little different direction. This says, where are the y values for f bigger than the y values for y? So y values for f bigger or equal to the y values for g. Now, if I look at that, that doesn't have a heck of a lot of meaning to me. Especially if I want to look at a graph. It just to me, it's a little bit too abstract. However, when I look at this right here, this also says, where is the graph of f of x? Now, if it's bigger, the y values are bigger, and the graph of f of x, is it above or below the graph of g? Above the graph of g of x. Now, that gives me a frame of reference. That says I've got two graphs. one graph is going to be above the other. Where does it occur? So where is F above G? And if you notice, remember, here's the graph of f of x, and here's the graph of G. Notice that the graph of f of x moved above the graph of g of x at the intersection. Up until then, the y values on G were bigger than the y values on f. Intersection. The intersection of the two graphs tells you how the graphs interact with each other. So that if I look at it, that says wherever they intersect or cross, one moves above the other. So in this case, it says, okay, they cross at x equal 2. And it says greater than or equal to, it's a solid dot. And from that point in time on, F is above G. So if I look at it on a number line that says what's going to be my answer is going to be x has to be greater than or equal to 2. That's what I found algebraically. It's harder from a graph. It really is. It's harder to read from the graph because you have to know what you're looking for. And then you have to really understand what it's asking for. But it's the intersection is the key.